This video is about review for derivative 1 without calculator. For 1a, let y equals x third power plus x to the 3 over second power. Find derivative of dy by dx. So dy by dx equals, we got to do the power rule first. So drop down 3 over 2, then we get x third power plus x. 3 over 2, you need to minus 1. Then you use the chain rule, do the derivative of 3x third power plus x. You will get 3x squared plus 1. Now we organize this value, that will be 1 over 2, means the square root. So you get 3 square root x third power plus x. Then over 2. Top, you need to multiply by 3x squared plus 1. This will be the answer for 1. Now go to second one. Let fx equals 2x over x squared plus 5. Use quotient rule to show that derivative of fx equals 10 minus 2x squared over x squared plus 5 squared. We do the derivative for f of x equals, we know this is a formula for quotient rule. If you have u over v, then you will get the v squared. Then the u derivative of v minus u times the derivative of v. Therefore, u will make x squared plus 5 squared. When you do the quotient rule of derivative or product rule of a derivative, write down the formula. In other words, I will write down 2x, we do derivative. Then multiply by denominator is x squared plus 5. Then here's minus. We do 2x times the derivative of a denominator, that is x squared plus 5. We do derivative. Now we try to simplify. Denominator won't change. X squared plus 5 squared. Derivative for 2x will be 2 times x squared plus 5. Then do minus here. 2x you stay. The derivative for x squared, that's 2x. For 5 will be 0. Then you will get x squared plus 5 squared. Distributive property, 2x squared plus 10. These two multiply, you will get the minus 4x squared. So we combine like terms for the numerator, you will get the 10 minus 2x squared, x squared plus 5 squared as a denominator. This means show that, just work this out, try to get the same answer as a given. Now let's go to 2a. Let theta be an obtuse angle such that sin theta equals 3 over 5. Find the value of tangent theta. First of all, obtuse angle means the second quadrant. All students take a calculus. You could see the tangent will be negative. So we will draw a coordinate. Since theta is an obtuse angle, so they go to the second quadrant here. This will be R. For the second quadrant, we count this is a theta. This will be positive y, here's negative x. Using SOHCAHTOA, sine will be opposite over hypotenuse. That means this is a 3, this is a 5. Using the Pythagorean theorem, you will get the x equals a 4. That is a negative 4. Therefore, for tangent theta equals opposite over adjacent, that means 3 over negative 4 equals negative 3 over 4. So we get the negative 3 over 4. Let's go to 2b. Line L passes through the origin and has a gradient of tangent theta. Find the equation of L. Gradient, that means a slope. So you get the m equals negative 3 over 4. You are given the point 0, 0. So we use a point slope form of a linear function. We can get the y minus y1 equals m, x minus x1. We plug in. Y minus 0 equals negative 3 over 4, x minus 0. Y equals negative 3 over 4x. So we write down y equals negative 3 over 4x. For 2c, let f of x equals e to the x power times sine x minus 3 over 4x. Find the derivative of f. For 2c, we will get the derivative of fx equals. For the first term, you have to use the product rule. Therefore, you do the ex power derivative times sine x, then plus e to the x power times sine x, you'll do the derivative. Then minus derivative for 3x over 4 will be 3 over 4. E to the x power derivative will be e to the x power sine x plus e to the x power times derivative for sine x will be cosine x minus 3 over 4. This will be the solution to 2c. Let's go to the last question. The following diagram shows the graph of f for x is between 0 to 3. Line M is a tangent to the graph of f at point P. Given that M is parallel to L. Parallel, that means they have the same slope. So you got the slope of this line, that will be negative 3 over 4. Find the x coordinate of P. First of all, we know the derivative of fx is the slope of a tangent line. Therefore, this derivative, it will be the slope of a tangent line for this f function. It will be equals to negative 3 over 4. So you get the e to the x power sine x plus e to the x power cosine x. Then minus 3 over 4 equals negative 3 over 4. We organize. This is gone. Then you can get the e to the x power sine x plus e to the x power cosine x equal to 0. Common factor will be e to the x power. You get the sine x plus cosine x, then equal to 0. As we know, e to the x power never be 0. Therefore, sine x plus cosine x equal to 0. So we get the sine x equals to negative cosine x. Then we divide it by cosine x both sides. You will get the tangent x equals negative 1. We need to solve this trig function. And tangent equals negative 1. That means we use all students take calculus. Tangent is negative. They go to these two quadrants. You can get the reference angle first. That will be inverse of tangent of 1. That's pi over 4. Therefore, for the second quadrant, you will get the 3 pi over 4. And the fourth quadrant, you will get the 7 pi over 4. Check the domain for x. It has to be between 0 to 3. Therefore, 3 pi over 4 will be the solution. So x equals 3 pi over 4. Let's go to 3a. Consider a function f. The line L with equation y equals 3x plus 1 is a tangent to the graph of f when x equals 2. Write down the derivative of f of 2. According to the concept, derivative will be the slope of a tangent line. For this tangent line, slope is 3. Therefore, we can get the derivative of f of 2 equals 3. How you get the f of 2? Suppose this is the f function, and this line is 3x plus 1. This is L. We could say if this x equals 2, then this intersection will be the point at the graph f. In other words, when I plug x equals 2 to this linear function, which is a tangent line, you will get y coordinate, which means f of 2. So 3 times 2 plus 1, you will get 7. 3c, let g of x equals f of x squared plus 1. P be the point on the graph of g where x equals to 1. Show that the graph of g has a gradient of 6 at P. We got to do the derivative of g of x, which means we do the derivative of f of x squared plus 1. So first of all, you have to do the derivative of f, x squared plus 1. Then you multiply. We use the chain rule, do the derivative of x squared plus 1. That will be 2x. We do know that x equals 1. That's the x coordinate for this P. So we plug in. You will get f derivative of 1 squared plus 1. Change every single x into 1, then times 2 times 1. You will get derivative of f of 2 times 2. Therefore, we already got derivative of f of 2 here. That's 3. So 3 times 2 equals 6. When you see the word show that, means you work this out. It's the same as you work out the gradient of the graph of G at P. Now let's go to 3D. Let L2 be the tangent to the graph of G at P. L intersects L2 at the point Q. Find the y-coordinate of Q. Let's sketch the graph. We do know the slope for this L2, that is 6. That's why when I draw the L2, it's steeper than L. L is y equals 3x plus 1. So we try to figure out this Q. First of all, you need to figure out the linear function for L2. This point is given is a P. I need a y-coordinate for P. So we plug x equals 1 to the G function. You will get the G of 1 equals f of every single x turning into 1 squared plus 1. So you get the f of 2. We already figure out the f of 2 equals 7. So equals 7. In other words, we know the coordinate for this P, it will be 1, 7. You can use point slope form to get linear function of a tangent line for this L2. Y minus 7 equals, slope is 6, x minus 1. Then I do distributive property organize. You will get the y equals 6x plus 1. The intersection, you need to solve these two linear functions. Since y equals, which means 6x plus 1 equals 3x plus 1. Then you can get 3x equals 0. So x equal to 0. Then you plug back to any of these two equations. I plug in y equals 3x plus 1 because it's easier. Y equals 3 times 0 plus 1 equals 1. Therefore, the y-coordinate of Q means 1. For A closed cylinder can with radius r centimeters and height h centimeters has a volume of 20 pi. Express h in terms of r. According to the formula, volume of a cylinder equals pi r squared h. Means the base area times height. Therefore, you can get the pi r squared h equals 20 pi. Since I'm looking for h will be the variable. Therefore, try to isolate this h. Get rid of the pi by divided by pi. Divided by r squared so that you can reduce this r squared both sides. So we do pi and r squared. Then reduce pi. You will get the h equals 20 over r squared. So h equals 20 over r squared. Go to 4b. The material for the base and the top of the can costs 10 cents per centimeter square. And the material for the curved side costs 8 cents per centimeter square. The total cost of the material In cents, it's C. Show that C equals 20 pi r squared plus 320 pi over r. Well, you need to figure out the surface area, total surface area. For the top and the bottom, that is pi r squared, you multiply by 2. Then you multiply by 10 cents per centimeter square. Then you add the curved surface area of a cylinder, that is 2 pi RH. Then you multiply by 8. This will be the cost. Organize, you will get the 20 pi r squared plus 2 pi r times h. We already figured out that's 20 over r squared times 8. So we reduce r squared, here's r. You will get the 20 pi r squared plus, denominator is r. 40 times 8 is 320 pi. When you say show that, means you try to figure out this C. Now let's go to for C. Given that there is a minimum value for C, find this minimum value in terms of pi. When you're talking about the minimum value, means we are looking for the derivative of C. And equals to 0. So derivative of C, you will get 20 pi times r squared will be 2r plus 320 pi times r to the negative first power. We do the derivative. This -1 you will drop down. So you get the 320 pi times -1. R do the -1 minus 1, that will be -2. So we organize, you will get 40 pi r minus, this is the r squared, 320 pi. We will set up this derivative equal to 0 to solve for this r. First of all, we try to get rid of this r squared. So every term for this equation multiply by r squared. You will get the 40 pi r to the third power minus 320 pi equal to 0. You are looking for this r though. This is a power pattern equation isolating this r. So we get the r third power. Move negative 320 pi to the right side. Don't forget the change sign. 320 pi. Then you divide it by 40 pi. Both sides. You will get the r to the third power equals 8. Then you know that r equals 2. Do the cubic root of 8 equals 2. Get the r equals 2. We plug into this formula for cost. You will get the C equals 20 pi times 2 squared plus 320 pi over 2. Then 2 squared is 4. 4 times 20 is 80 pi plus 160 pi. So your answer will be 240 pi. Make sure 240 pi will be the solution because they said find this minimum value in terms of pi. You have to use 240 pi as the solution.